Day 69 of doing a LeetCode problem every day until I get a job. Hi guys, and welcome back to another day, another LeetCode problem. Hope you guys are ready to do some LeetCode today. I hope you guys are still motivated, still disciplined, and not feeling any type of burnout because we have a long way to go, guys. We're only day 69 out of who knows how many, so you need to just stay focused, keep going, and push through. If you're feeling burnt out, don't even worry about it, guys. You might feel better tomorrow, or you'll definitely feel better in a few weeks or a few months when you start to realize all the things you've learned over this time and all this hard work is starting to pay off. Now, guys, with that being said, before we get started, don't forget, bring your mouse right over here and click that subscribe button for me, guys. Then after you click that subscribe button, go ahead and smash that like button for me. Then after you smash that like button for me, guys, I need you to go ahead into the comment section, and I need all of my bankers out there to go ahead and drop a bank emoji in the comment section so we can run this engagement up. We could bring more awareness to the Swift community, and we could welcome more people into the Swift community, guys. We're trying to build the Swift community up. We're trying to get it popping. We're trying to get it known. We're trying to bring more awareness to Swift. So the more people that do Swift, the better, guys. Now, the part that you've all been waiting for, the main event, the main attraction, the question. Today we have question number 162. Find peak element. The difficulty level is medium, guys, but you already know we're gonna keep the solution as simple and easy to understand as possible because we're all trying to learn here, and there's no point in writing code that nobody understands. So we're gonna write some code that everybody hopefully can understand, and we all could actually learn something. Now, if we want to know what the code says, first thing we need to do is understand what the question says. So let's go through the question and read through the question and see what it says. So it says, a peak element is just an element that is strictly greater than its neighbors. Given a zero-indexed integer array nums, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. You may imagine that nums -1 equals nums n equals negative infinity. In other words, an element is always considered to be strictly greater than a neighbor that is outside the array. You must write an algorithm that runs in big O log n time. So, excuse me, guys. Let's break that down and look at the question or look at the examples and see what they mean. It's really not that difficult, though, guys. We just want to find the index that has, well, what does it say? The index that's that is an element in the array that is strictly greater than its neighbors, guys. So here we have an input nums, an array of integers. The output is 2. The explanation, 3 is a peak element, and your function should return index numbers 2. So if you look at this array of integers right here, you'll notice that 3 is a peak element because it's greater than both of its neighbors. Its neighbors 2 to the left, 3 is bigger than 2, and its neighbor 1 to the right, 3 is greater than 1. So that is the peak element because it is strictly greater than both of its neighbors. But we will return 2 because we are returning the index, not the value of the element. So remember, it was zero indexed integer array. So this would be index 0, this would be index 1, and 3 falls on index 2. That's why we're returning 2, because we're returning the index, not necessarily the element in the array. So just in case that didn't make sense to everybody, let's look at example 2. It's the same logic, but you'll see in example 2 it's a little different. I'll show you why. So we have input nums, which is an array of integers. The output is 5. The explanation, your function can return either index number 1 where the peak element is 2 or index number 5 where the peak element is 6. So in this case they return 5. The output was 5 because if you count, we go 0, this is 0, 1, 2, 3, 4, 5. So 6 is the peak element because if you look to the left, 6 is greater than 5, and if you look to the right, 6 is greater than 4, so it counts as a peak element, and that it falls on index number 5. That's why we return 5. But if you notice, we also could have returned index number 1, which would be 2, because this is also a peak element, because if you look over here, look to the left, 2 is greater than 1, and if you look to the right, 2 is greater than 1, which makes 2 also a peak element, which falls under index 1. And it says up here, it says if the array contains multiple peaks, return the index to any of the peaks. So we could have returned either 1 or 5, but in this case they chose to return index number 5, which the element is 6, which still works because it's still a peak element. So that's just an example of how there could be 2 peak elements in the same array and you could return either one. So let's see how we're going to code it. The code is not that difficult at all. I actually like these kinds of questions. We're still in the LeetCode 75, and yeah, so let's see how we're going to code this. The first thing we're going to do, we're going to declare a variable called L, and we're going to set that equal to 0. Then we're going to declare another variable called R, and we're going to set that equal to nums.count minus 1. And with these L and R, if you don't know, L stands for basically left, the furthest side of the array, index 0, and R stands for right, the furthest, the index to the furthest right of the array. So, excuse me guys, one more time. L stands for left, which in my mind signals that it's the furthest left of the array, and R stands for right, which signals it's the furthest right to the array. So that's where LR come from. Then we're coming down here and we're saying while L is less than R, then we're going to come down here, we're going to say let mid, and you guys already know how we find mid. We're going to open up the parentheses and we're going to say L plus R divided by 2. And what that's going to do is that's going to find us the middle of the array, so we could iterate through the array faster because we're starting from the middle instead of starting from the end. Then we're going to come down here and we could say if nums mid is greater than nums mid plus plus 1, then what we are going to do is we are going to set R equal to mid. We're just going to say R equals mid. Then we're going to come down here, we're going to say else L equals mid plus 1. And this is a while loop, so it's going to loop through this as long as R is greater than L until we find our output, and then we will return R. And that's all, folks, or that should be all. Let's run it and see what it says. Fingers crossed. And it's accepted, guys. Oops, I gotta let it chill out a little bit. Seems I've been running or submitting code too fast. So give it a few seconds before I submit it again so we can see what the time is. Let's submit it now and see what happens. See if it lets us go. Let's see, fingers crossed. And it's accepted, guys, with 8 milliseconds, and it beats 82.82% of users with Swift, guys. Now, that's what I'm talking about. That's what I like to see. And I also would like to see you guys tomorrow for another day, another LeetCode problem. Peace.